Good morning, students. Welcome back after first term. We have already covered two chapters in first term, motion and force and laws of motion. What did we learn in these two chapters? In motion, we learned about motion of objects in straight line, and in force and laws of motion, we talked about the cause of motion. I hope that you must be clear with all the concepts of these two chapters. Moving further with the syllabus, let us move on to a new chapter, which is gravitation. Gravitation would be chapter number 3 of your syllabus. So first of all, let us try to understand the meaning of gravitation. What is gravitation? Gravitation is a phenomena. It is a phenomena of attraction. It is a phenomena of attraction between any two objects between any two objects which have mass. It does not necessarily mean that attraction between Earth and any other object. It can be any other object. The objects may be terrestrial, means the objects may be on the Earth, or it can be celestial also. Celestial means outer space objects such as stars, planets, satellites, etc. The objects can be of any shape, it can be of any size or different mass. The simple concept is a phenomena of attraction between any two objects which have mass is called gravitation. Now there is a famous saying, I think most of you must be familiar with that saying. It says, everyone saw the apple fall, everyone saw the apple fall, but Newton was the one to ask why. Now this question was there in his mind, that why does the apple fall down? Why doesn't it go up? And this led to the law of gravitation, which is also called Newton's law of gravitation. What is Newton's law of gravitation? Newton says that if we have any two objects, let us say these are the two objects, let us say A and another object is B, and the distance from their centers, let us say this is R. R is the distance of separation between the two bodies. And let us say M1 is the mass of A and M2 is the mass of B. Newton said that these two objects will always attract each other. A would attract B and B would attract A with a force. And this force is directly proportional to the product of masses, means F proportional to m1 into m2. This is the first thing. And the second thing is force is inversely proportional to the square of distance between the two objects. Means F is inversely, so it is 1 upon r square. So if you combine these two statements, this becomes the Newton's law of gravitation. So let us combine these two statements now. Combining both of them, we get F is proportional to m1 m2 divided by r square. Now mathematically, if you remove this proportionality sign can be replaced with an equal to sign. So F is equal to, when we remove the proportionality sign, we put some constant, multiply m1 m2 by r square. This constant is represented as G, m1 m2 by r square. This is F. Now what is this G called? G is called as the universal gravitational constant. Now if you look at the equation, F is proportional to m1 m2, directly proportional to m1 and m2. Means if you increase the mass, more is the mass, more would be the attractive force. Similarly, if you look at this statement, F inversely proportional to r square means more is the value of r, lesser would be the attraction. So F is proportional to m1 m2, F is proportional to 1 upon r square. So ultimately we get this F is equal to G m1 m2 by r square. This is called as the mathematical statement. This is the mathematical statement of Newton's law of gravitation. Now this G is the universal gravitational constant. The value of G is equal to 6.67 into 10 power of minus 11. The unit is Newton meter square per kg square. Now how do we get this unit? Let us see. If you look at this equation, F is equal to G m1 m2 by r square. Take G to one side. If you take G to one side, you get F r square by m1 into m2. What is the unit of force? Unit of force is Newton multiply. R is distance, so it is meter square divided by kg multiply kg. So ultimately you get the unit as N is Newton meter square per kg square. You need to remember these values. Now you will learn in higher classes how the value of G was calculated in the laboratory. It's a famous experiment. Now, once we know the value of G, if we know the value of M1 and M2, we can very easily calculate the force of attraction between any two objects. So let us do some calculation. Now, before we do some numericals on this topic, let us first try to understand what is the importance of the universal law of gravitation. This also sometimes comes in the exam. Importance of universal law of gravitation. Now, universal law of gravitation is very helpful in explaining why the planets revolve around the sun. Means it can be easily used to talk about the motion of planets around sun. It is all because of gravitational force. And the second thing, we can in the day-to-day life we can see the rainfall, snowfall. This is all possible because of gravitation. Water droplets falling down. You must have heard about tides, high tide, low tide, where the moon attracts the earth. It cannot attract the earth so strongly, so what does it do? It attracts the water body. So you can see huge waves on during high tides, and during low tide the water moves down. Then you can predict even the solar and lunar eclipse using universal law of gravitation. It can very easily explain many phenomena which happens in our day-to-day life. Okay, so let us try to calculate the gravitational force. First of all, let us take light objects and then we will move on to the heavy objects. We know the value of G. G is 6.67 into 10 power of minus 11 Newton meter square per kg square. This value is very, very important. You need to remember this. Now, before we move on to the other numericals, let us first try to define G. So, what is the equation we get? G is equal to Fr square by m1 into m2. G is equal to Fr square by m1 into m2. So, if m1 is equal to m2 is equal to 1 kg, let us take 1 kg each, and R is equal to 1 meter, then what do we get? Then G is equal to F into 1 square by 1 into 1. So we get G is equal to F. So how to define G? This is only for definition of G. G is numerically equal to the force of attraction between two objects each of mass 1 kg and separated by 1 meter. So this is the specific definition of G. Now, if we take 1 kg each, let us take this as the first example to solve. Let us take this example. M1 is equal to 1 kg, M2 is equal to 1 kg. The value of G is 6.67 into 10 power of minus 11 Newton meter square per kg square, and R we are given 1 meter. So what is F? From here we can calculate F. F is equal to G M1 M2 by R square. Keep writing the formula repeatedly so that you can remember it very easily. This is 6.67 into 10 power of minus 11 into 1 divided by 1 square. So how much do you get? You get how much? It's a very low value. You get 6.67 into 10 power of minus 11 Newton. And this value is very less. Or we can say negligible. So what happens? We cannot see the force of attraction between two objects which are kept very close to each other, having mass 1 kg. So this force cannot be felt. This force can't be felt. Now the second thing, let us take a mass of 1 kg and the earth. Let us say the question is calculate the force of attraction between the earth and an object of 1 kg kept on its surface. So if you see this question, let us draw a diagram for this. So let us say this is the earth. First of all, let us draw the circle representing the earth. So this is the earth. And we have an object which is kept on its surface. So let us say this is the object. And this is the earth. Object has a mass of 1 kg. And what is the mass of earth? Mass of earth is 6 into 10 power of 24 kg. Mass of earth is equal to 6 into 10 power of 24 kg. And this radius, if we mark the center from center to center, this radius of earth, this is r, the value of r is 6400 kilometer. So if you want to find out the force of attraction between these two objects, one of them is the earth and the other one is a small object of mass 1 kg. So let us put the values. F is equal to G M1 M2 upon R square. So this is G is 6.7. We will take 6.7 for calculations because this makes the calculation a little bit easier, rounding off. Then mass of object is 1 kg and mass of earth is 6 into 10 power of 24 kg divided by r square. Now this 6400 kilometer, if you change it into meter, it would be how much? It would be 6400 into 1000 meter. So it is 6400 into 1000 whole square. Okay. So how much do we get? Let us solve it now. This is 6.7 into 6 into 10 power of minus 11, 10 power of 24. So it is 10 power of minus 11 plus 24 whole divided by, I can write this as 64 into 64, multiply. Here 2 zeros, here 3 zeros. So 10 power of 5 whole square. Okay. So this is 6.7 into 6 divided by 64 into 64 into 10 power of 24 minus 11 is 13 minus 5 square is 10. So we get 10 power of 3. Okay. Now look at the calculation. We will use approximation here so that the calculation becomes easy. How to do the approximation? 6 ones are 6 tens are. It is very close to 64. And similarly 6.71 and 6.7 into 10. Nearly it will get cancelled by 10 times. So if you can use even your calculations, if you have a very good calculative skill, then you can multiply 6.7 into 6 and then 64 into 64, you will get the same values. So we are getting 1 upon 100 into 10 power of 3. So ultimately the answer is 10 Newton. So a 1 kg object gets attracted towards the earth with a force of 10 Newton. Now this 10 Newton is it's a good value. We cannot neglect this 10 Newton. So we can see the object coming down. Okay. So with this way we can do some calculations. Now this is another question. Let us see a question. This will be your homework. Homework question number 1. You can try these two questions. Calculate the force of attraction between the earth and the moon separated by a distance of 3.84 into 10 power of 5 kilometers. Now what are the values you require? You need the mass of earth and mass of moon. So mass of earth is given 6 into 10 power of 24 kg and mass of moon is given as 7.4 into 10 power of 22 kg. You know the value of G. G is to be taken as 6.7 into 10 power of minus 11 Newton meter square per kg square. Now do this question as homework. Next time when we meet, we are going to discuss more numericals on gravitation and explore more about the topics. Thank you very much.